Okay, good morning. I am a major in the Air Force, so by my watch it's 8 o'clock, so we're going to get started. And this session is AB 204-6, Flagship BIM, Designing and Building the U.S. Central Command Headquarters in MacDill Air Force Base in Florida. My name is Major Pat Sewerman, and briefing with me today is Steve Klein from Burns & McDonnell, the AE of record on the project. And we'll show you a picture here. These are the two facilities we're going to be talking about today primarily. The one on the right that you see, is JICCENT, the Joint Intelligence Center for Central Command. And that facility is already done. I got to tour that facility in October. And the one on the left is the CENTCOM headquarters. That's the one that is going to be LEED Gold certified. It had a building information model done for the design, which is what we're going to talk about today. And you might notice, though, that it looks almost the exact same as JICCENT, and that's by design. We call it the fraternal twin of JICCENT because in order to speed the design along, they used the footprint and the structural steel skeleton as the basis for design of the CENTCOM headquarters. So there are some differences, but they are going to be very similar. But it provided a great case study and kind of a microcosm of the whole industry on a design that was done in 2D and then moving towards a BIM-enabled 3D design with LEED and with a lot of other extras and add-ons on this project, enhanced commissioning. And we're going to talk to you just about our journey today that we've had in the last year and a half or so. This project is not by any means cutting edge, I don't think. We did some things that are definitely unique and we learned a lot, but many people in here might do things that they might have a lot more knowledge in certain areas, but we look forward to hearing those questions at the end and hearing your comments on the things that we talked to you about today. But this mostly is just trying to show you the things that we learned on this project, and we think it's going to be a strong basis and a foundation for how we do our future work in our just about $2 billion a year in the Air Force. So I usually like to start out, I'm going to tell you what I'm going to tell you, and I tell you, and I tell you what I told you. It's an old military thing. And so this is the session. We're going to talk to you today about what the differences were on those two projects for 2D. We're going to talk about how LEED played into it a little bit. We're going to talk about the added benefits that we didn't even know that we were going to receive during this project. And then we're going to talk about the future expectations, how we're shifting in the Air Force as the owner from the things that we realized on this project that we want to see that were successful and that we would like to see on future projects. Just a little background about me so you know the lens that I look through, the perspective that I bring. I've spent obviously way too much time in school, so I like to dream about things that could be done and don't always know what should be done or how it could be done, and that's where I rely on people like Steve who actually do things. But I first came into this project in the summer of 2008. I was in a hotel in Washington, D.C., and I got a phone call from Colonel Beam at CENTCOM headquarters, and he said that we got this project, and we want it to be BIM, because we want a flagship facility for CENTCOM, and we really want it to be nice. And that's pretty much the first sentence he said. He said, we want a flagship facility, we want BIM. And I said, well, why do you want BIM? And he said, well, I just think that would be good. And I also want it LEED certified. And I was like, okay, well, LEED and BIM I don't think really go hand in hand. I mean, there are benefits to both, but he just sounded like one of the kind of guys that it was ripe for doing a lot of work and was really proactive and wanted to do good stuff on this project. So I said, okay, well, I know something about BIM. I can help you there. But first you had to figure out, well, why do you need it? And he told me about the JICCENT project. I don't know if you've ever had this or not, but that project didn't go completely smoothly. There were some challenges, especially with the coordination of all the mechanical and interstitial space, and they raised computer flooring and some pretty advanced stuff in the place where we store all our information about bad guys for the whole world. There was a lot of stuff to put in there. So that's where I started to realize, okay, well, we know about the clash detection and the conflict resolution that we could have in BIM. We know about the visualization to try to show people like General Petraeus, the new CENTCOM commander. There's a pretty high pucker factor on this project because there's a 4-star general in the building. And so I was like, okay, well, I'm starting to see some reasons why we would want to have BIM on this project. So we decided to go with that. So I initially came on and I went to a design charrette in August where I went to the wrong day though. They talked about LEED the whole day. And I wasn't a LEED AP at the time, and a lot of the stuff I was just trying to go off of some stuff I learned from my class at Florida. But I started out initially being kind of a lead consultant on it, and but primarily BIM, and trying to tell them what are the types of things that we should expect to do on this project. But the good thing is, I graduated, I finally got out of school, and I went back to work for a living, and now I work at AFC, which is the Air Force Center for Engineering and the Environment. In 2007, they centralized all the MILCON management for the whole Air Force to AFC. In fiscal year 2009, we had a record execution rate, and we're finally starting to figure out what that actually means. And we're doing a lot better job now at AFC of managing our MILCON. We broke down the stovepipes of how it used to be managed by all the different MAGCOMs across the globe. So that's about me, and then I'll have Steve talk about himself.
Okay, thanks, Patrick. My name's Steve Klein, and I'm a structural engineer. That's my main job at Burns & McDonnell. I've been there since 2004 full-time. And I also have this sort of secondary role, and that is as our Aviation and Facilities Group BIM implementation leader, sort of a member of a team of folks on that. And as Patrick's, similar to Patrick, I've had plenty of years of schooling, but not quite as many. I haven't gotten the PhD thing behind my name yet. But my role on this project was really as BIM advisor. I didn't get to do any of the fun structural engineering stuff on this one. I basically helped advise the team early on in terms of what direction we were going to go and what tools we were going to use. So with that, I'll hand it back to Patrick.
Okay, a little background about, if you don't know what CENTCOM is, it's U.S. Central Command. And as you can see, the area that they're in charge of, a lot of things have been happening there recently. And I get to help them out in February. I'm going right there. So that should be interesting. And I just talked to one of my friends yesterday, and he says I'm going to be sleeping either in a trailer or a hole. I can't remember which one he said, but looking forward to that. But so CENTCOM has been around for a while, and they've been really working out of a facility that doesn't mirror the high level of ops tempo and the types of things that they accomplish. So there was a renovation, an alteration, and an addition that were slated for fiscal year 07 and 08, but the bids for the alteration came in 4 times higher than were programmed. And steel was going up, and it was at a time of a high on the economy, and so they kind of went back and they replanned, they retooled, and they reprogrammed to try to just make it all into one big addition, and it worked out really well. Nothing is easy in the government. There are a lot of stakeholders in this project. It's an Air Force project because it's an Air Force base, but the Air Force does not do their own design and construction. We use our agents, which are the Army Corps of Engineers or the Navy Facilities Command, and this project, since its location, is done by the Army Corps of Engineers Mobile District. So we have people from Alabama coming down and working on this project, managing the design, and then we have the AE Burns & Mac. The general contractor is Clark, and then the owner is CENTCOM, which is not only a joint command, but a multinational command. When I was down there at JICCENT, there are people from every service and all over the world working in this building. So starting to see a lot of the reasons why we need better communication, better coordination, and I think BIM helped accomplish that. This is the kind of stuff I already talked about. These are the steel prices. When those bids for the FY07 and 08, I think, went out, it was right probably, I guess maybe, let's see, here's 08. It was probably right about in there. So I think it was probably more of market forces and the drivers of the economy as opposed to just namely steel prices, but it wasn't good. And overall, they decided that new construction would be a lot better way to go. And they just got congressional approval because of the same funding and the same fund source, and then they just reprogrammed the project and went forward with the new construction. This is CENTCOM as it stands currently at MacDill in Tampa. This was phase 1. It was built in 1982, going to phase 2 and phase 4. And it's no accident that it just looks like 3 big rectangles, and that's exactly what it feels like when you're in this building. You walk into what looks like it was probably a wall, and then all of a sudden there's a staircase and disjointed doors and strange hallways. It's very odd. And so they're really in dire need of a new facility. This is JICCENT under construction. It is now completed. You can tell that it doesn't really look like it meets the base architectural standards for you Air Force architects out there, but it is a SCIF facility. The whole facility is a SCIF. It's a secure facility, so it does have the standing seam metal roof on top of the concrete roof, and CENTCOM is the same. When they decided to do the CENTCOM headquarters, they at first had, you can see this is kind of early on in the process. It's only 3 stories. But I don't know about you, but we don't usually put a 4-star general in a building that's shorter than the building next to it. So we decided to, like I said earlier, match up the CENTCOM headquarters with the JICCent and use the economies of scale in that existing structural design that we already had. Later on, I don't know where this came from. I got this from CENTCOM, so if somebody here has more information than I know, I don't know what they used to get this, but just kind of giving you more of an idea of the area. Later on in the design, this was all before I came on board, you can see that they're starting to match each other. They're both 4 stories. And this is the mechanical plant over here that serves as for the air conditioning and the mechanical for these 2 large buildings. And then this is kind of orienting you to the site again. As you can see, not only were these 4 phases disjointed and not really adequate, they were even putting people out in trailers because, as Mike Lilia, the facility manager, described it to us, every time something new is in the newspaper, that is when they would have new facility requirements. If something's happening in Djibouti, they're going to stamp a new team that handles whatever is going on in Djibouti. If something's happening in the Helmand province of Afghanistan, they're going to stand up a new team. And so they have these different courses of action all the time that they're briefing to their senior leaders and their facility managers on, okay, we're going to bring in 20 people here, we need comm drops here, we need this kind of service for them. And these facilities needed to mirror those needs. And I thought this picture was a really good example of that. Here's JICCent. That's the front of it. There's the back of CENTCOM. The new CENTCOM headquarters is going to go right here. They're out there. They're prepping the site now and getting ready to put caissons or piers. Okay. Okay, yeah, they're prepping the site now, dewatering and everything. And then once that is demolished, we do have a definite parking problem. They're going to be doing a parking problem or parking either a garage or a large parking lot. They're still kind of, I guess, deciding. And the building should be done, CENTCOM should be done in about 2011, summer of 2011, and then the parking problem should be fixed by summer of 2012. So overall, what's the bottom line? The JICCent job cost $115 million, and the CENTCOM one only $61 million. Can we just say, oh, that's all due to BIM? Definitely not. That would be irresponsible. But I do think it helped make sure that we had a level of design and certainty of design that mitigated a lot of risk for Clark to build this building, who also built JICCent for almost half the cost. So millions of dollars saved, and definitely a good news story on this project overall. So the Air Force is going to get what they want, and CENTCOM headquarters gets what they need. But then we had the challenge of actually designing this building, and that's what Steve's going to talk to you about next. And there's things that they knew and some things that they didn't know. And I'll hand it off to Steve.
All right. Thanks, Patrick.
Thank you.
Have you guys seen this quote before? You remember hearing that? He was testifying in front of Congress. So I'll give you a minute to read it. I think it's a great quote. You know, I think it's really one of Donald Rumsfeld's better quotes. There's known knowns, right? We know what those are. There's the known unknowns, the stuff we know that we don't know yet, right? And then on a BIM project like this, there's a bunch of unknown unknowns. And for us, there were quite a few of them at Burns & McDonnell that we ran into along the way. And we'll talk about kind of all those different things. But first, I get a chance to blatantly plug our company. Burns & McDonnell's been around since 1898. We're 100% employee-owned, and we made Fortune's 100 Best Places to Work last year, so we're pretty proud of that. We've got 3,000-plus employee owners, and this is our headquarters building, and we've just made it Energy Star rated, and we're shooting for a LEED Silver rating for existing buildings. Working on that right now. So, as Patrick was saying, Lieutenant Colonel Jay Beam wanted this to be really a flagship facility. And he talked about some goals that he wanted us to think about as we're moving forward with this design. It's flexibility, because as Patrick was saying, there's all these different missions that are going to be taking place throughout the life of this facility. And the facility manager, Mike Lilia, is telling us, hey, I need to be able to reconfigure space very quickly, to send out RFPs and understand what's in the wall and that kind of thing. So that was really important. Staff comfort. these kind of operations are happening 24/7. So we've got people in this building all the time. They may be there multiple shifts. So we definitely want to make it comfortable, architecturally appealing. Again, if we've got a 4-star general in there, you want the place to look decent. A little bit nicer look than maybe you're used to seeing on military bases. Sustainable and innovative, and I think the BIM aspect really brought the innovative aspect to this job, and we're hoping that the transition to the FM tool is also going to make it very innovative for us. So the way we started approaching this was as BIM advisor to this project. The project manager came to me and said, okay, hey, we're getting started. I need to get us off on the right foot. Not sure exactly how to do that, and what I suggested is, hey, we need to get everybody together, all the stakeholders together, and Patrick, I think, was on board with that and came to that very first meeting that we had, where we had Mike Lilia, who's the facility manager. We had Autodesk Production Assurance, who was nice enough to come and join us there and help advise us. We had our IT group, our Geographic Information Systems group, all of our engineers and stakeholders from kind of both sides. And at that meeting, we kind of talked about all the different things that we were going to be doing, how we were going to use BIM, and how we were going to integrate it with the FM tool. And that is one of the biggest lessons learned, I think, on this project, and we'll talk more about that as we go through. We ended up shooting for LEED Gold on this project, and we think we're going to get there. So if you could, and using enhanced commissioning. So I'm going to talk first about, the traditional 2D toolbox that I think we're all pretty familiar with. If we were doing this in 2D, we would have had one CAD tool, AutoCAD. We would have done clash detection by hand, right? I would have gotten a set of plans from the mechanicals, and the architect, being a structural engineer, I would have gotten a set of architectural plans, a set of mechanical plans, and would have gotten out my calculator and started figuring out, okay, where is this duct really located? Is it going through one of my beams? Do I need to call that guy up? Or hey, is there a slab penetration that I don't know about? So on those traditional 2D projects, that clash detection process is really a by-hand process. Now maybe I'll open up an AutoCAD file and turn on a reference and do some checking there, but it's a slow process. You're liable to miss a lot of things because there's no automation to it. Then our facility management tools that we normally deliver, right, are a set of paper as-built drawings and then a set of O&M manuals. And you just hand it over and it goes in some drawer somewhere, right? So that doesn't really work really well. So what we wanted to do here was think about what our BIM toolbox is going to look like. And I think the first thing that you'll notice is there's a whole lot more parts. So we've got Revit architecture, Revit structure, and then what we used on this one for the MEP aspect was AutoCAD MEP. For coordination and clash detection, we use the Navisworks tool, which I think is pretty ubiquitous at this point. And it works really well. We've got some processes that we use to pull all those models together. Of course, that's the easy part. The hard part is how do you walk everybody through all these models and really get some good input out of it, because you can get sort of lost in there. So now the facility management tool at our preliminary meeting was a big question mark. So we had Autodesk there and we talked about FM desktop. And it seemed really cool. We were all really excited about it. But the thing is, it's a government job, right? So we can't just say, okay, you guys go out and buy this tool. They have to put it out to bid, and best qualified bidder is gonna get it. So we really didn't know. We knew that being a core project, they were gonna be requiring a COBE worksheet as part of the deliverable. Actually, why don't you tell them what COBE is? I think you know it a little bit better than I do. Yeah.
Okay. COBE is the Construction Operations Building Information Exchange. COBE was made by ERDIC, the Engineer Research and Design or Development Center out of Champaign-Urbana, Illinois. And the end product is just a big Excel workbook. Mm-hmm. And its intent is to take all of the pumps, the mechanical equipment, everything that's got a serial number and some warranty data, as opposed to just not knowing what that is and giving you a bunch of junk in a box. Right. We want to have all that loaded in one spot that's tied to the spaces, that is also hyperlinked to the warranty information and the PDFs. It's an Army initiative, but something that we thought would be very beneficial on this project to meet the needs that Mike Lilly was talking about in that initial meeting in September. And this part was definitely still experimental, and so there are things that you can do to get information out of the BIM and into COBie, or there are things that you could do where you could just walk around an existing building and populate this workbook and still have the COBie deliverable. So they're not, COBie doesn't necessarily mean BIM, and BIM doesn't necessarily mean COBie, but there are things that you can do to hand off information electronically and avoid a lot of the paper and the things that are lost and not used. So
it's a big step up from the box with the paper in it and the O&M manuals. So
that's what COBie is.
Okay. Thanks, Patrick. Sorry to put you on the spot there.
That's fine.
You can go ahead and advance it. So you're probably all familiar, hopefully, with what Revit looks like, but we're going to talk a little bit about the level of detail that we got into. Before we do that, we're going to compare the 2D process that we would have used with the BIM or 3D process that we ended up using. There's so many things that are different. I'm on a 2D project right now. It's driving me nuts because I have to redraw all this stuff. But access to information is one of the most important and easiest benefits that you get out of the model. You know, I click on the wall and it tells me all this information about the wall, right? Another really important thing, I think, for us and for our clients is understanding of the facility. Just as an example, I've been working on a National Guard project in Ohio, and we got to the 35%. We sent out these 35% drawings. The client had a chance to review them for about 2 weeks, and then we went up there and had a design review meeting. So we're sitting in the design review meeting, we're flipping through their comments, and very few comments. But what I did was, as we were sitting there, I brought the model up on the screen, and as we were talking about a particular room, I would sort of virtually walk us into that room. And then some light bulbs started going off, and what I realized is that our client doesn't read 2D drawings on a regular basis. So he's not used to doing what engineers and architects do every day, which is visualize the space in his head. So what we did is we visualized it for him by putting it up on the screen. And some important things were learned in meetings like that. Like we walked him into his office space, and he's, you know, whoa. He wanted half walls instead of full height walls because he didn't have a furniture budget. So he was going to cheat by building half-sized walls and then bolting countertops to them, you know, because that can be part of the design or part of the construction budget. So level of detail is a really critical thing, and we're going to talk a lot about that as we go through today. I think especially when you're thinking about using this model in the end for facility management, knowing how it's going to be used, what pieces of information are going to be beneficial to the client in the end is a really important question to ask, and we had some definite lessons learned there. So duplication of data is a pretty obvious thing with BIM. You know, you click on the wall, the data is already in there, so if you want to make a schedule, you just make the schedule and it populates everything, so there's not that duplication of typing things in. So. Okay, so at that early meeting that Patrick was in, we talked a lot about level of detail. And as I mentioned just a minute ago, it's really important, especially when you're integrating with a facility management tool in the end. In 2D, you know, the information that's in the CAD drawings, it's a 2D Etch-a-Sketch, right? It's just lines, and you point at them, and you call them whatever you want to. But in the BIM world, the data's in there, so it's got to be right, and you can go crazy with the detail, and sometimes that's needed, and sometimes it's not. So, without having an answer to what the FM software tool was going to be, what we tried to do was really pick Mike Lilia's brain and just to sort of try to think like him as we're going through the project. And we did have an advantage that our lead architectural Revit operator had also been a facility manager in the past. So she had that background to be able to think about, okay, well, as a facility manager, what kind of information do I really need to have in the model? So, go ahead.
I wanted to say something about that.
Okay, yeah.
That was one thing that this meeting was primarily that we're kind of talking about chronologically was September of 08, but we had another meeting in September of 09 where we looked at the BIM after it was done. And I was so excited because the BIM manager numbered all the rooms exactly like Mike Lilly was going to have the numbers of the rooms. And to me, that was a surprise because I've been on many projects where the architect just numbers the rooms for their sake, but it has nothing to do with how the building numbers are actually going to be laid out. And then that's one of the first steps that the facility manager is like, well, thanks for all those numbers, but now I'm going to go through there and number all the numbers of the rooms. And so that's already all completely done, and we already know where people are going to go. And it's just those types of small low-hanging fruit that just made this project so much better, and that was one thing I was really happy about.
So to talk about to talk about level of detail, are you guys familiar with the AIA E202 document? Yeah, okay. It's a really good way to have a conversation about level of detail. So we know that we as the AE firm on a traditional design bid build job, we're never going to get over here into the shop drawing, fabrication drawing, and as-built stage unless that's part of our contract, because that costs a lot more money, right? But what we are going to do is we're going to have some things that are just 2D representations, so just lines, potentially. Okay, we're going to have probably a lot of generic elements, so maybe like a VAV box. Maybe you put that in as just a rectangle and you give it a simple a name of a VAV box. But then we're going to have probably most of our stuff in there at a level 300. So this is elements that are, they're defined geometrically. They look like they're supposed to look. They have dimensions, capacities, maybe even connections, although with structural we didn't go that far. So that was kind of a good way to talk about this. And now they've got a long spreadsheet that comes with this that you can go through and really define things out. And we didn't do that on this project, but I think that was kind of a lesson learned. And as a result of this project, what we've done within Burns & McDonnell, within our division, is sat down with each of our disciplines, so structural, architectural, mechanical, electrical, and said, hey guys, we need to define what our standard level of detail ought to be on these projects, so that if the client, what we'd like to do is have the client tell us, hey, here's exactly what we want, but in the absence of that, we want to be able to, for our benefit, have that level of detail, standard level of detail established. And it's not only for us, but it's also for our clients, so that we can help them by saying, hey, here's what we're going to give you. You're asking for BIM. You may not have decided what BIM means to you. Here's what it means to us, so here's what we'll deliver for you. So, okay, so here we are. We're trying to think like Mike Lilia. So we're trying to read somebody's brain, which is usually never a good idea. But we know we want flexible space. So we want to talk about, he needs to know if he's going to move a wall, does that wall have an STC rating? Does it have a SCIF rating? Is the VAV box that's above the ceiling serving this space or serving another space? So those are the kinds of questions that we're trying to think about as we're putting this model together. So here's an example from the architectural model. This is a little section cut here, walls selected, and then here's the properties box for that wall. So you can see, not only is there the tag for the wall, so if you want to go to the wall schedule, you can see it's a P1A, but you can also tell that the wall is SCIF constructed. So that way, in the end, Mike Lilly has got this, he's going to have this model, it's going to be updated by the contractor, and he will know what he needs to do with that wall. Here's a shot. This is actually, it's kind of, you have to think about orienting yourself. This is the front entrance of the building. The Navisworks model, we've got architectural, structural, mechanical, and electrical all turned on there. The architectural is sort of faded. And we're just going to kind of talk through some of the level of detail that we went to on this model. So not only did that wall tell you that it was a SCIF wall, but it also tells you what size studs are in the wall, so that, again, if he wants to move that wall, he knows what studs he needs to go by. So that's pretty detailed stuff. There's a parameter in that wall family for the final paint selection, so that when Clark Construction actually paints the wall, they can key in, here's the type of paint we used, so that, again, if you need to repaint it, you can do that. our architect, the lady that did most of our Revit architecture work happens to have been a professor of architecture and also taught Revit architecture at Kansas State University. So she really knew the program really well. So we were really impressed because she's got little false joints in the precast. She's got those modeled into the Revit model, which I was just amazed. I still don't really know how she did that. So, and of course we've got the piles modeled in on the structural model. So. Oh gosh, and there's more detail. The wall placards, okay, when you go into and out of a room, they're in the model. And all the data that's supposed to show up on the placard is in the model. So again, if Mike Lillia needs to rename a room, he can go and he can pick on that wall placard and he knows what data is on it. Very detailed. Fire rating, wall finish, handrails on the stairs, and she even went to the extent, and this made me laugh, of all the toilet accessories, all the Bobrick numbers for each, for the toilet paper dispenser, it's all in there. So as you can see, we spent a lot of time putting a lot of detail into this model. A lot of sleepless nights for architects and electrical and mechanical engineers. And it was tough. It was tough for everybody on the project because we had a really compressed schedule, and we didn't know how to budget for this. So that was really a challenge for us in terms of trying to actually, we're in the business of making money on these things. Trying to actually make money on this was a challenge. Okay, we're going to get into the mechanical MEP side of things. So every pipe was modeled. The only piece of pipe that was not modeled, because I didn't really believe that when the mechanicals told me they had modeled every pipe. The only pipe that wasn't modeled was that little flexible fitting that's under the sink that connects to the faucet. Okay, that's it. Everything else was in the model. You can see all the diffusers, the ducts, the VAV boxes. And this gets back to, we'll talk a little bit about lessons learned later, but I want to hit on one here, which is that if Clark Construction had been on board at the beginning, then we would have had a conversation with them about, hey guys, aren't you going to have your MEP subs who are going to be fabricating this stuff model all the duct in MEP, right? So maybe we would just in the future do just a schematic level model for the MEP side, and then if Clark's on board, then we can just have their subs fill in. Because what's going to happen is that when Clark's guys do the as-built model of all these ducts, they're just going to delete our part out. So all this work is going to sort of go the way of the dodo. So go ahead. This is a rendered view of our pump room out of Navisworks. So there again you can see the level of detail we went to on the pumps. Probably more than you really need to do on a project like this, but people like to see what their pumps are actually going to look like. So we went ahead and got a pump from a manufacturer, basis of design, and put it in there. On most projects, what we would probably do is we would have a box, just a generic shape that's got the properties, right? And it's got where the fittings need to be, but it doesn't really need to have all these shapes because that really can bog down the model. And it did bog down the model in some cases. Okay, on the electrical side, we've got light fixtures, panels, communications antennas were a big deal. And you won't see any of them on here because they required that we take those off for presentations and that sort of thing. But it was really important for the client to know, with their communications antennas and the type and the direction that they're pointed, be visible from the ground. So we were able to put all that in. And then the other exercise for us on the communications antennas was, does the roof pitch work with the comm antennas? So we really modeled that to a high level of detail. This is just a shot of one of our electrical rooms, and you can kind of see there's a lot more generic shapes here in the electrical room because there's not a whole lot of components that you put in those. So,
another thing I'm going to interject here is that, and just to corroborate Steve's story, the Air Force new requirements for BIM design only require that you model everything that's 1.5 feet in diameter and above. And when we got this model back and we started seeing conduit and, I mean, cubicles and the extreme level of detail, it really set the bar very high. And these are the types of things that the top tier AEs are going to start to differentiate themselves on projects like this by going that extra mile. And that's one thing that we feel that Burns & Mac really did on this project. So it was really good.
Thanks. So here's kind of a shot again of our Navisworks model, and here you can see how all the electrical rooms stack up in the building. So that's kind of cool. So I asked, these electrical guys were telling me all this stuff they'd thrown in there, the conduit all the way down to 1.5 inches. And I said, well, there's got to be stuff that you didn't model. And oh yeah, there is. It's the thermostat on the wall and the wire from the thermostat back to the equipment. That was not modeled. Structural connections were not modeled. And as I said a minute ago, any electrical conduits smaller than 1.5 inches. So. And this is just a Navisworks shot. We've kind of turned the architecture off. The structural's kind of hidden. And there you can see the mechanical and electrical systems in the building. So pretty extensive. Kind of hard to follow if you're just flying through the Navisworks model on your own without any guidance. So from the level of detail discussion and all the exercises that we went through and sleepless nights and stuff like that, as I mentioned a few minutes ago, we really are putting a big emphasis for us internally on establishing a standard level of detail. And what we're doing internally is we've got an intranet site within the company focused on BIM. And so on that site, we're going to be posting, or we have posted documents related to our best practices in terms of how we should do BIM, BIM planning and that sort of thing. And one of the really important things that we're going to have on this intranet site is a matrix of what our standard level of detail should be. Because really, for us, it shouldn't be this. Because if we're going to do this level of detail, we're going to have to charge a lot more, and we're not going to win projects. So it's just something we have to be aware of. But what we do want to do is establish that if the client is interested in having something that's at this level of detail, that we can provide it, and we can understand for ourselves what it takes to get there. So, okay, you have to have, if you're doing a BIM presentation, just so you know, you have to have this chart in your presentation. Is that right? Does everybody agree? Okay. So what we wanted to do, what we all think BIM will do for us, right, is move from this traditional curve, move that design process earlier, and move those big decisions earlier in the phase of the project. And so I was really curious because we had JICCent, right, which was done 2D, and then we had CENTCOM, which was done in BIM. And they're the same building, right? So can't I just plot the hours next to each other and see how that looks? So I did that. I got the data out of our system, and this is just billable hours that we spent along the project time. And I just sort of aligned the projects to start at basically when the first jump was in our billable hours. And so you can draw whatever conclusions you want from this. Looking at two projects is not a good way to make any conclusions. But I'm going to do it anyway. Okay, right? So you could see the highest peak moved up, right? So that sounds good. Now there's factors in there that play into that, like the schedule was compressed. Okay, so maybe that was what caused that big hump of work to happen a little bit earlier. I don't know. Take it for what you will. I just thought it was kind of interesting to see how those things, how that happened in the real world. So this is what our marketing department thinks a clash detection meeting looks like. Okay. But I'm right here, so I was kind of a party to this. So anyway. I think the important thing that we did capture here, we're using Navisworks. We've got touchscreen panels that we use on some of our projects. The important thing that you're capturing here is that everybody's in the same room together. And I think on a lot of projects, in the old way of doing things, the coordination and clash detection is expected to just sort of happen naturally, because you're going to pick up the set of plans from the mechanical or the architectural, and you're going to flip through and you're going to find things and you're going to talk to them. And yeah, of course, that still happens on BIM projects. But the other thing that happens that we do now is really a ritual on projects that are using BIM technology is we have a BIM manager for the project, right? The BIM manager brings all those disparate models together, sets up the clash detection sets, lets everybody know where the file is, so that we have some engineers and architects who are really getting into Navisworks and just flying through it on their own and telling the mechanical down the hall that he's clashing with the electrical on here and there. So making that available, I think, is an important thing. But then the other part of the BIM manager's role is to guide these discussions. So we obviously, you can't fly through, you saw how complicated that Navisworks model is. You can't fly through that whole thing and try to get much out of it. But what you can do is you can say, hey, next week's clash detection meeting, we're going to clash architectural with, let's say, mechanical on the first floor west end. And so you go through all the clashes there, you talk about how we're going to resolve those clashes, and then you move forward. So as I was saying earlier, traditional process, flipping through drawings, trying to punch things into your calculator, figure out where this pipe really is. Is it really a problem? How long is that bend radius, that kind of thing? That takes a lot of time. This is just intuitive, right? You just open it up, you fly to these points that it brings you to, and it's just blatantly obvious. It's really easy to see how you solve these things. So our BIM manager set up all these clash checks, all these batches, and we first ran it, and there's 8,000 plus clashes in this model. Pretty scary. Anybody that sees that for the first time may kind of freak out, because you're going to go, how am I going to go through all these clashes? Well, what you find is that so many of them, and those of you who have done this, have experienced this, I'm sure, so many of them are okay, and so you can approve them. Like all these lights here, they're touching the ceiling. The lights are in the electrical model, they're touching the ceiling, which is in the architectural model, and that's good. You want those things to be clashing with each other. So when you approve lights touching ceiling, then you just wipe out 1,000 clashes for every, however number of lights you've got. So that was in March. By December, one thing we had done is we had limited the number of batches we were really looking at. Now we expanded that again later to get more detail, but here we've got a few less clashes. Go ahead. Now at the end, we want to deliver a clean clash detection report, right? So we at least establish here that we have no new clashes. Now we do have some clashes that are still existing, and those had all been approved or noted at the time that we were done with the project. So, and you can see the detail we got with the different clash reports, because there's so many and it's so hard to go through them all. But if you can kind of break it up by floor and you can break it up by system, it makes a lot more sense. And some of them are more critical than others. Like here, you don't see architectural clashed with electrical, because switches, conduit, they go through walls all the time, and that's okay. But where you do have problems is when you have mechanical going through structural. Obviously, it's a really big problem, especially for me, since I'm a structural.
I'm going to jump in and say something.
Yeah, absolutely.
This was one of the definite lessons learned on this from an owner's perspective and maybe from an AE perspective. Mm-hmm. When we got the final model, CENTCOM is busy, waging our nation's peace, and so they're out there working hard, and they don't have a lot of people to look at construction drawings all the time. So they have 2 employees who are contracted out to help them on this process for these giant projects that they have coming up. And they sent, Burns Mac sent the model, but they didn't have Navisworks. And I did have Navisworks. So they said, we're going to send you the drawings. Will you run the Navisworks model on them and then tell us what you see, and tell us if this is worthy of 100% sheet set? And I said, okay. So I just brought it up in Navisworks and said, run all versus all. And I had 0 level clashes, and this was the Navisworks run that I ran, and then I just said, okay, and I just sent them off and said, here you go, 8,000 clashes. And they're like, what? And so the same thing that Steve was saying, I mean, so it was a little bit of managing expectations on, I think that's something that we should have been a more informed consumer and asked for something that was more explicit or less explicit probably. And maybe Burns Mac should have said, let's come meet with us and we're going to walk you through this part. So that's something that we're going to definitely do in the Air Force is spell that out and spell out relationship and definitely manage those expectations, because then we got into, I mean, all kinds of things where we're like, well, this is a contractor telling a contractor what to do, and I mean, all those types of things that just really make a wicket even stickier. So this is something that is a new emerging capability, and we want to make sure that we set ourselves up for success and leverage that capability in the best way, as opposed to it being a source of contention.
Right. Yeah. You can go ahead and advance it. That's basically what I was going to get to, which is
sorry.
No, that's fine. That's fine. Which is that you really do have to manage expectations. If your client has Navisworks, fantastic. And I think one of the important things that that Patrick would probably agree with me on is you've got to share the model. Because it is really beneficial for your client to see the model and to see what their facility is going to look like throughout the process, so that those decisions can get made earlier. And it's really important to talk to your client about what this model that you're sending is. So, you know, if you send a Navisworks model at 50%, and let's say you've got all these batches set up, it's so easy to just, you know, for the client then to just run it and go, oh, well, you've got all these things and they're not resolved. Well, you need to talk to your client about that before you send it to them, to say, hey, you know, we're at this stage. We know we've got this situation in terms of clashes in the model, and here's what we're doing to resolve those. So, you know, prepare, you know, don't be alarmed when you see that there's a lot of clashes in the model. So we want to be able to share that information, and we want to be able to have that conversation with a client. So it's, you know, it's an education process really on both sides. So on the lead side, as Patrick mentioned, lead and BIM, I think there's definitely some overlap, and I think as we move forward with BIM and as it advances, we're going to see more and more integration with lead tools. I went to a presentation yesterday talking about green building systems and ecotech and how they're integrating with all the BIM applications out there. And you know, what he was telling me was, well, yeah, we maintain two separate models. We maintain one to do the lead analysis, and we maintain another one to do our design work. So on this particular project, we did go for LEED Gold. We've got 42 LEED credits. But we really, I can't say that we used the BIM side to achieve those LEED goals. So our energy analysis and that kind of thing was outside of the model. So hopefully we'll get there in the future, though. So yeah, you can go ahead and advance it. So this is what Burns & McDonnell did. What I call the design intent model. I think, I'm not sure where I got that name, but I've heard it around. We do a design intent model. We want to communicate with the client and with the contractor what our intent is, right? Now this was a really detailed design intent model for us. So then Clark Construction comes along, and they came along much later in the game than we would have preferred, but here they are. Now they've got a contract with the Mobile District, and their contract includes, of course, building the building, but it also includes delivering an as-built model and that COBE worksheet. Okay, you can go ahead and advance those. So at the end, you know, at the beginning of the project, we had this big meeting and we talked about, well, how are we going to do BIM on this project? And then at the end of the design process, as the contractor's coming on board, then we had that same group of people come together again, but now with Clark, to talk about, okay, how are we going to make this next leap? Because ultimately, what we want to do for Mike Lilia, the facility manager, is provide him some kind of facility management tool that he can use in the end. So the core district did their part by contractually obligating Clark to deliver an as-built model and the COBE worksheet. So we talked with Clark about, well, how are you guys going to achieve that? And they brought their subcontractors to the meeting as well. So we started talking to their subcontractors about, well, do you normally use AutoCAD MEP to create fabrication models? And some of them said, well, no, but we're going to now. We're learning it. So the MEP systems in this building and fire protection, as well as steel, I guess, are going to have fabrication models from those subcontractors. So that's fine and good, but what about the architecture, right? Because the architecture's got all this important data in it. So if you can go ahead and advance it one more time. The way we think this is going to work, and the picture we drew together with Clark was, okay, the fabrication models of these systems are going to replace the design intent models for those systems, right? Because the fabrication models have so much more information in them than did our design intent model. But for the architectural aspects, which will have no fabrication model, because right, the drywall contractor doesn't create a fabrication model, right? He just doesn't do it. So what Clark will do is they will take our Revit architecture model and they'll work it to update it for the actual dimensions, and I'm sure that there will be modifications during the construction phase, and they'll get that model updated and have that information in there. So that'll come together as our as-built model. And sort of as a parallel process, they're getting all this information about equipment in this COBE spreadsheet. Now, the kicker is that you've got to have some correlation between those two things, right? So if in the fabrication model a VAV box is identified with a particular number, you've got to have some kind of that same piece of data in the COBE spreadsheet, because in the end, if you can go ahead and advance it, those two things have to come together in our facility management model. And the way to do that is you take the model data and then the spreadsheet data, and you say, okay, if these numbers correlate, then you bring all that information together. And what we envision happening is that probably the COBE spreadsheet will sort of, as a one-time use, go into the fabrication model. Is that what you're picturing happening, Patrick?
This is all those lines, if they're not dotted, should be probably dotted there at the end.
Yeah.
Because that is working with A7C, which is the civil engineer of the Air Force. They're working in parallel trying to figure out how our future facility management is going to be. I noticed there's somebody here from Archibus, and that's good, because we might do Archibus, we might do Triga, we might do Allplan. We have all these different approaches that we want to make sure we're doing our asset management. And it's in my mind, I'll be doing my job when I make sure that our BIM models are properly handed off. It'll be like, we'll be the Tim Tebow, and the FM model will be the Riley Cooper, and we'll catch the ball, and we'll get a touchdown. And that's my hope. So that definitely on the FM. Was that all you're going to say on the other part? Because that's something else I was going to say.
Well, I guess I was going to add also that at the time we drew this picture, we still didn't know, and we still don't know today, what that FM tool is going to be. So these are ideas, and this is how we picture it happening. But in terms of how it's going to really work in the end, we'll have to work with whatever vendor ends up winning that contract.
And then in the red box, we probably should have made it blue, because Clark's color is blue too. But they remember when I said 115 million versus 61 million? Well, that's good and bad, because now we've got all these new things and some initiatives that we wanted Burns and Mac to do, and they seem like they really took them on full force. But Clark now is kind of saying, oh man, there's really thin margin on this job, and I don't know. And so we're trying to set them up for success. And one thing that I've found that people don't like academics, because they like to say how much they know instead of helping people actually do things they need to do. But I'm trying to help them by giving them somebody who can do the things that they need to do for very cheap. So we've got a PhD student who really does know what she's doing. She did BIM modeling for contractors around Florida, and now she's in her PhD program. We're embedding her at Clark, and she's going to help them modify and maintain this BIM model and help them integrate it into their workflow there in the construction trailer. And that's, I think, academic stuff done well, is when you help people meet a need that they already have, as opposed to just going, here, let me come give you a PowerPoint. That doesn't do me any good. So. Yeah. That's my job, to give useless PowerPoints. But, okay.
Yeah, well, it'll be exciting to see how that works. So lessons learned on this part in terms of the FM side is, It's really ideal if you've got that decision made early on, because then you can really talk about what are the key parts that we need to get in our model, in our design intent model, and what are the key parts that are going to come from the fabrication models. I think the other part would be nice to have Clark on board early on so that we can talk to them about that kind of thing. And really talking about, if you know how the BIM, the FM tool is going to be used, what are the really important things? Is it really just moving walls, or do you want to be able to tie in your building operations system with all that FM data, which is, I think, where we'd like to get in the end. So really talking about what's the future going to look like. And I think I'm hoping that all those lessons learned end up coming together as a way of doing business for us and for the industry. So we all know that BIM is really beneficial, or ought to be really beneficial, for the facility manager, right? But getting there, it's kind of like the presentation from that we saw yesterday, starting at the end, which is having a really beneficial tool for the facility manager, and then working backwards is kind of, I think, where we need to get. So looking first at how does this integrate with the facility management tool. For us, talking about level of detail is going to be really important, because we want to make money on these jobs and not just do really, really cool stuff. So I think as more content becomes available, I think Autodesk Seek is a great source for us. But also, with the level of detail in this project, we had to upgrade our hardware in the middle of the job. So managing the level of detail, not only on our side, but in that content that we get from Autodesk Seek, is really important. Because if we're going to download the real pump, and it's got all the nuts and bolts and rivets in it, that's really going to bog down our model, and then you start running into hardware problems and that kind of thing. So. And I'm going to talk about, that's my last slide actually on CENTCOM. I want to talk about where Burns & McDonnell is going with these ideas. This is a project that we're doing for the Albuquerque district. It's called the Battle Lab. And on this project, we're not calling it IPD, but it really is, because from the beginning, it's a design-build job, and from day zero, right, before we even responded to the RFP, we had our contractors and our subcontractors on board, and we knew that they were interested in participating in the BIM process, so they were able to participate in those early decisions, share some of the risk. And what you can see here is what we did on this job is what I talked about earlier, which is that our engineers did schematic level designs of the mechanical and electrical systems, and then since our subcontractors were on board from day one, and actually steel as well, our subcontractors were able to take those schematic models, turn them into fabrication models, and then share them with our engineers throughout the process. So it was kind of a new thing for them, because subcontractors are used to getting a complete set of drawings, right? And then if they're going to do a fabrication model, they'll do it once, and then they're done, and then they build it. Maybe they go through a review process. But on this one, because the subcontractor is involved in the design process, they're really having to go through that iterative process that all designers have to go through, and that was kind of a new experience for them. But I just want to share a quick story about the benefits of BIM for us on this job. I was talking to our mechanical engineer on this project, and he's been around a long time at Burns & Mac. And at the beginning of this project, he was really, really tentative about doing this project in this fashion. But I visited with him after the design had pretty much completed, and I asked him how it went. And he told me that he couldn't envision doing a project without this process. And I was floored, and I said, well, why? What happened to make that change in your mind? And he said, well, it's kind of that process that I was talking about earlier for clash detection, where you'd get your calculator out. Well, the way he designed his systems in the past has been to figure out how much space he needs above the ceiling. He would just sort of find the deepest beam on the structural plans, find the bottom of that beam, look on the architectural plans and find where the ceiling is, and then just a subtraction there, and that's the space that he used. And if he had done that on this job, and he did that process on this job, and he said, well, that's not big enough for my ducts, he would have needed an extra foot per floor to make this building work for him. And we were already down the road. We had already, won the contract and down the road with the design when he discovered this. But what he was able to do, because the subcontractor was on board, was he was able to bring that problem to them and say, okay, here's my schematic layout for this system. I don't think it's going to work because I don't think there's enough room above the ceiling. And that subcontractor took that and in their fabrication model routed the ducts and that sort of thing and sent it to him and said, hey, here's a solution where I think we can make this work with the building at its current height. And he was good with it. And so in the end, we were able to save 2 feet of height on the entire building, which would have been a really expensive change that we at Burns & McDonnell would have had to eat. So just kind of a lesson learned for us. So we're going to tell you what we told you, right? So we compared the 2D process, talked about the benefits and the challenges that we experienced, talked about LEED and really maybe kind of the lack of integration between our BIM model and our LEED analysis. And I think any of the other stuff on there, you'll just have to hit us up during the Q&A to tell us we did or did not do it. So.
Yeah, the main thing I would just say is that we were really excited to give this presentation. When I came to AU last year, I hinted at the type of things we were doing on this project, but I really didn't know how it was going to go because we had a lot of people doing things that weren't required, and I thought maybe some of the motivation and enthusiasm would sputter out. But as you can see, Burns Mac really took it on. I think Clark is really excited. We got a good email from that same person who was very upset at CENTCOM about the clash report. Just wrote us about 3 weeks ago and said that they were very excited that the subs were doing clash detection and conflict resolution on this job, and it went really well. And we're starting to really see a lot of good things happen from this. And so I'm excited that we're actually able to fill our time with a lot of good things, and I appreciate Steve and Burns & Mac and the Clark team, as well as Army Corps of Engineers. I know they're in the room. And at this time, we'll take your questions.
You had, now presumably, you had the Clark construction on the CM, correct?
Yes, but not until later.
So presumably the set of documents you're putting together were going to be an open bid set of documents. I'm assuming that's how you
I believe so.
operates.
Is that right? Yeah.
I'm sorry, I was slipping. I didn't hear the question.
It was an open bid situation.
When the project is finished and it goes out to bid, it's an open bid, correct?
That was one weird thing that I asked the PM about, because I didn't understand, because since I was at the University of Florida when this project went out, and as some of the stuff I told you about the 07 and 08 alteration and addition, I didn't understand if it was recompeted for design, or it seemed like it went straight to Burns & Mac. But typically, yes, we go out for every project and we compete them. But this one, I think because of the way that it was lumped in with Jixon or something, it was not. But it was competed for. It was traditional. It was design, bid,
Are you
build.
asking really about Clark's role?
No. So
okay.
I'm trying to set up a question.
Sure. Okay. All right.
What that's getting around to is, it was just a small example that you presented, but you were showing your toilet room accessories schedule.
Right.
And you had populated it with
Right.
manufacturers.
Right.
This is an open bid project.
Right.
You're going to waste your time doing it.
Yeah, and that's a good question. And and you saw pumps in there. So what those are basis of design kind of things. And of course, our specs have to list multiple manufacturers. But for visualization purposes, what we would do is we'd put in the basis of design.
So in the case of the pump, that makes sense to me. But again, just as an example with it,
Right.
there was extra mouse clicks
Oh, yeah.
going on to input that information that may not in fact be a part of it.
Right.
I think a lot of that really went to the initial meeting in September of 08. I've never been to a design charrette like this where, and it's not an exaggeration, for the first hour, Mike Lilly, that facility manager, he's probably the most sophisticated FM guy I've ever seen, because he knew what he wanted. And he was very specific about it. There was 25 people in there, and they all just sat there and listened. And he got everybody so motivated that they're really trying to please him personally, that's the kind of things that they went into. And I mean, it sounds kind of...
I think what it does is it establishes a placeholder. So, okay, let's say it's not a Bobrick. Let's say it's some other brand. If Clark's role is just to update that model, then they'll go, okay, well, we didn't, the data spot is in there. And so they can go, okay, well, we didn't do Bobrick, we did this other brand, and so they can replace that data. So, and hopefully it'll be useful to somebody down the line. So, yeah.
When the project went out to bid to Clark, was the model given them at that time? Did they utilize the model when they were putting together bid packages, or was it not until after the award that you actually shared the model with them?
Yeah, so the question was, did Clark get the model at the time of bid? And I don't know the answer to that. Do you know?
Yes, I know we had it available. There was a regular set of construction drawings made on this project. And while I'm doing this, I'm just going to play this because I feel bad for Steve. I forgot to remind him to play this earlier.
Oh, that's okay.
But they got the regular set of construction drawings. That's always good.
Uh-oh. Darn.
And so that's probably what they primarily bid off of, especially judging by the meeting that we had in September of 2009. But they did have the model available to them in both Navisworks and Revit. And I heard through the grapevine later on that
There it is.
they did route that through their Bethesda main office. And what level of detail they used in for bidding out their project to subs and everything, I don't know, because that's internal to Clark. But it was made available to them, and that's something that I want to have on all future projects.
I don't know if they even had Revit at the time. There was a question in the back earlier to get answered. Okay.
How large was the file?
The file, I think, the architectural Revit file, I believe, was broken up, but I think together it was close to 300 meg. So it's pretty big. I think what we had to do was we had a there's a switch, 3 gig switch, and we had to do that on all those computers. I think that was all we ended up having to do, but it was really a challenge. And even for the structural that was referencing in or linking in that Revit architecture model, we had to put some workflows in there, and actually I think we used the work sets so that we didn't have to have the entire architectural model on at that time. So.
You spoke briefly on levels of detail.
Uh-huh.
I'm just curious on the mechanical system, since they use the AutoCAD, what level of detail were they able to, if you're no longer able to have that, the tag detail that you would for the project, what level of detail did they achieve?
Well, the mechanicals, they modeled, like I said earlier, they modeled all the pipe, they modeled all the duct, they put in all the equipment. Now, in terms of how much data was tied to that, not a whole lot. Not a whole lot. And I think for that, we've got to lean on those fabrication models with the COBE spreadsheet to get all the valuable data into that FM system. Does that answer your question? Okay, okay. Yeah, go ahead.
This great level of details, how did it, I'm curious to find really help in terms of use casters, RFIs to a great extent that it could have made
Sure.
it cost effective?
Yeah, so the question was the number of the work spent on as-builts and the number of RFIs get reduced. And I think we don't know the answer yet because they're just sort of breaking ground. We did hear, though, along those lines, our structural sub told our structural engineer that this was the best set of contract documents that he had ever seen. And I think that was from two things. One aspect was that we're starting with the JICCent job, and then we're copying over. So that helped us learn a lot along the way about what our documents look like. And it was also doing that clash detection exercise and really having those things fleshed out. So we're hoping that the number of RFIs is a lot lower.
Let's answer or have the question. There's somebody sitting on the floor. I feel bad
Oh,
for you.
okay.
Do you have a question over there?
Uh-huh.
How large was the facility and how many discrete spaces did it have?
It's 265,000 square feet.
Yeah.
And
I don't know the
I don't
answer
know how
to
many
your other
spaces.
question. Yeah.
I mean, I could query the model and tell you, but I don't have it with me.
Yeah.
Said you had a hardware upgrade in the middle of the project. Do you remember this fact?
Yeah, the hardware upgrade in the middle of the project, I think we just did that 3 gig switch. The hardware spec for those machines, I don't know. Jeff might know. You don't know? Okay. All right, Jeff's in our IT group. What's that? We added physical memory to a lot of them. Okay, okay. Did you have a question up front? Yeah.
On the dirt road, HVAC,
right size, it's locating the position. What design information was in the ductwork? Was the air volume measured up?
Yeah, was there design information in the ductwork? And I think the answer to that is not much.
The one thing I was going to ask too, I mean, so some of this I don't know since you guys designed it, but you said some of the tagging and other things that you do in Revit MEP, and there's some analysis that you can do in Revit MEP. But I thought when I talked to your mechanical guy, he said that he ran train trace on it. So
Yeah.
I know there's other stuff that's outside Autodesk
exactly.
suite, and so I thought there was enough attributes to run the CFM analysis and train trace. So it had something.
I think that one challenge that Burns & McDonnell is really running into is, you know, we've been around since 1898. We've got a lot of folks who have been there a long time.
That's a really long time.
Yeah, oh man. So we've got a lot of folks who've got these old established processes of doing things. And one of the big challenges for us is getting our engineers and our architects to participate in the modeling process. So we need to, you know, we're trying to move beyond the, you know, your red line a drawing and then give it to a detailer or a technician, to where there are certain aspects that the engineer needs to do in the model. So when I do a structural Revit model, I have who we used to call a drafter. He goes ahead and lays in the columns and the footings, because I can tell him, hey, the architect and I have talked about where the grids are, and so all I need you to do right now is start by matching their grid lines, putting columns and footings in at those locations, and then as I design those elements, I go into the model and I update the member sizes and the foundation sizes. He maybe I have him get the foundation schedule ready, and then I can enter the reinforcement that's in that schedule. I can enter the reinforcement that's in the slab and that kind of thing. Yeah.
Right.
Question. I noticed that you use multiple platforms. You guys were using Revit and MEP was using AutoCAD. I'm sure in the fabrication models they use those different products. Do you feel that you would have been as successful had your client or the managing agency, say in this case Mobile, dictated to you the means, the methods, or the tools, the BIM software you use?
That's a good question. So the question was, if the Mobile district had said to use one particular BIM platform, wink, wink, you know, what would it have done to our process? And you know, what we talked about with our clients is that this is our preferred process right now, but we recognize that we need to have the ability to do BIM in a number of platforms. And it's not just the core that has some requirements. We've got other clients that are telling us, well, you've got to do, not only do you have to deliver the file in this other format, but you have to do the work in this other format. So it's a challenge that we're running into, and you know, this is our preferred platform because we are most efficient in this platform. So
Does that mean your fees would be higher if you're less proficient in another platform?
well, if our project managers all knew, you know, what the differences were, and we had it, you know, well established that, well, if we do it in this platform, it's 20% more. You know, we don't have enough data right now to be able to even say that, I would say. We know that we're less efficient, but in terms of quantifying how much less efficient, you know, our electricals and mechanicals, they get better efficiencies actually in some other tools. But architecturally and structurally, we're definitely most efficient in the Revit tools. So,
Take the back corner over there. Sorry.
yeah.
Yeah, I just wanted to come down because now we're talking about format, and I'll say the word on the IFC. Are you working in that direction, or do you see future?
Yeah, are we working in the direction of using IFC? And
Great. Thank you very much. I'll write you.
I would say we would like to say yes, and that was a direction we wanted to go on this project. And actually, our lead architectural person in the Revit model was a part of the IFC committee and developing that standard. And from her perspective, she said it's not ready, and that the export didn't give you all the data that you needed. and that basically that the IFC format really wasn't ready for the level of detail and the level of information that's in there, that a lot of the data would be lost if we went to IFC.
No, I can answer that a little bit too. I think IFCs are sometimes kind of polarizing, but I was an author on the National BIM standard, and so whenever possible, when I put that hat on, I like to be a proponent for IFCs. And when we were drafting up our requirements for the Air Force for using BIM, I didn't want to require BIM unless we were going to use it for something. And I was wrestling with that idea on what I was going to use the IFCs for. So I talked to Bill Napier in Wisconsin, who is also going through a similar process. And they are similar to us. We're going to say we like IFCs, we support IFCs, but we don't have a discrete business use case for them right now. So it's something that I don't want to be tied to a software company. I want interoperability, I guess, is my overarching strategic vision. But we also want the most data value in its richest format. So if we can meet both of those, we'll try.
And we want interoperability too. I mean, we'd love to get to a place where we can have one design application and then it's interoperable enough that we can just output in whatever format is needed.
Yeah, we do, and that's one thing too. If you have, I'm glad a lot of questions are geared towards an A&E firm, because I'm glad I have Steve here, because I wouldn't be able to answer them. But we do have another session at 3 o'clock. If you do have like what is the Air Force doing on BIM, or what's going on with BIM in the federal government, I have that session at 3. So if you want to go to that, or we'll be open and available after this. But it looks like a lot of good questions. I'm glad about that. So I'll go with this guy with the over here. For this project?
Yeah, they require all of the sheets to be produced in CAD files to be a certain
That
projects that have really had a huge amount of extra work that is required from AutoCAD to meet a USA requirement.
Well, your question is, I mean, your experience is definitely accurate, and I know a lot of people have told me that, but your question was a lot of parts because you asked me about 3 different things. The National BIM Standard doesn't have any requirement per se. It's mostly like we want to start to get to the point where we exchange information, and it's not like the National CAD Standard in that it says these layers will be like this and do this line thickness. The Air Force Standard, and I'll brief that more at 3, but we do have strangely enough, we also called it Attachment F. I wasn't part of that decision, but it's the same attachment that the Army has, but modified for the Air Force. And the gist of that Attachment F mostly says, we want you to use BIM. Come up with a BIM plan, and then whatever you tell us in that BIM plan, that's part of the contract. So don't shoot for the moon in there. Put what you really want to do, because that's what you're going to then be held to. So try and manage those expectations again, and make sure you're clear. And don't get one of these people who, well, I saw that we could do this crazy garbage with it. What I've seen in the government is a lot of people will just read one article, or they'll see everything that's on a checklist and they'll say, okay, we'll just do all those. We can't do that. We need to be serious and actually do what is going to be beneficial on the project and really think about those things early on. So that's what I would try to do with your clients. We'll get one over here and then we'll get back over there.
He's picking now.
Is there a second level of spatial coordination going on now with Clark and their subs?
Spatial coordination in the building, or you mean like geospatial?
Spatial with the Belt 3? Or is that not happening? Are they accepting that model?
They are. When I got that email, it was kind of out of the blue, and I was surprised that the subs are doing that coordination right now. And I'm trying to stay out of their business because, one, I'm not the PM on the project. I'm just sort of this BIM person hanging over their shoulder. And the PM has made that clear to me on this project. She doesn't really want me in her business. But yes, they certainly will, and that's what we wanted to be done on this project. So, and luckily, they seemed really all for it in the September 09 meeting. And so I think we have a good team there, and they will be doing that, yes.
What's the design schedule for CENTCOM?
Oh, that's a good question. I think it was in the neighborhood of 6 or 7 months.
I think you started you had a 15% design review that then decided, okay, let's go lead in BIM. That's what I got called in July. And in August, that was like a follow-up, redo hold. 15% design
Yeah, it was kind of on hold, wasn't it?
And then in September, though, when we got to, a month later, we got to Kansas City and looked at the model, and it really looked like it was at the 60, 75% completion mark because of I just blanked on her
Yeah,
name.
Vicky,
Because
the
of Vicky
architectural,
Borchers.
yeah.
And and then it was pretty much done by December. It was unbelievable. I mean, it really,
It was
I
a
mean,
lot-
for the
a lot
amount
of
of detail that was in
sleepless
that
nights.
building, it was unbelievable.
What's the proposed construction schedule?
It's going to be done in the summer of 11, and they are doing site prep now, and they're I guess driving the piles or doing the geotech first, and then it's supposed to be done in a year and a half. So it's pretty fast.
How does that compare with JICSENT schedule?
It's going to be faster because JICSENT had delays because of a lot of the coordination. And one of the things that was a problem was they crammed everything into the raised computer flooring. This project will have a lot of the comm and other items in the raised computer flooring, but then the mechanical is going to be in the interstitial space, which they have a very high clear story on this. It's like 16 foot per floor. So there's a lot of wasted space in my mind in JICSENT. Then we caused these problems in the computer flooring. So this project I'm almost certain will go a lot faster. There's a project down here in front. Or a question?
Yeah.
Which part of BIM was used for the structural design? Because everything that you said is about the architecture, mechanical,
Right.
other things that you are
Sure.
structural engineer.
Yeah, I can answer that question.
Will you repeat
Yeah.
the question?
RISA, robots, what was
We used RISA. So we had the structural analysis model from the JICSENT building, and we took this part off, and we moved the entrance, and then in our RISA model, we ran it, and then we took our RISA model and brought it into Revit, and that was our basis. Now we did not round trip that. We were actually using this was done in Revit 08. So we brought it in once, and then we nudged things here and there where they needed to be. So
the model was simplified first, and then the main part was moved to RISA one direction.
it was moved. It was not bidirectional. It was moved from RISA to Revit one time.
Okay, so every updates were made by yourself.
Correct.
Okay, update this model.
Right. Yep. Yep.
And today, how?
Today, how would we do it? I think we have a tendency still, and this may be just the mentality of our structural engineers, to do one directional. And I think that's because we feel like the structural engineer needs to be keeping control of that analysis model, and I think that the folks that do our Revit models at this point aren't focused on the analytical part, and so while they may be moving members, they may not be moving the analytical part correctly, or if we add a beam here or there. So that's the kind of issue we're dealing with.
Great.
Yeah.
Have you found a way to quantify the numbers of what 50% DD of a CAD project is versus 50% DD of a BIM model? How do you do that from the top down, time-wise, and does the document come up with a...
Yeah, that's a great question. Have we found a way to quantify the difference between a 50% CAD set, is that right, and a 50% BIM set of drawings? And the answer is no, we haven't. We haven't spent a whole lot of time. We've said, oh, hey, they should be different, and I've definitely made an argument that our clients should start thinking more about model reviews early on rather than paper drawing reviews, because with that hump of work moving earlier, our models get pretty well developed early on, but in terms of the sheets, and that's a problem even internally for folks that aren't in the model, they go, well, where's my drawings? Well, we've got this really great model, so what I would argue is that we need to, as clients, be thinking about let's focus more on reviewing the model at that 15%, 35%, 50%, and there's got to be some drawing review, but maybe not the level.
That's why in
that we
September
have.
of 08, we brought up the model progression specification, and even I knew of it, but I didn't know all about it. So we all sat in Excel and looked at it for a while and said, okay, well, that's sort of equivalent to 35 review, and this is that. So we used that as a way to start to get a meeting of the minds on how we were going to do it, but there should be something more formal.
I think I've come up with a solution to it. You print out the Revit model in sheets at 15% of Revit. It should look like 50% DD of CAD to kind of make the plans look the same.
Okay, send me you have the task here for that. Send the answer to me.
We'd like
and
to
then
see that. We'd like to see that plan.
Modify it and make it the
So
airport standard.
what you're saying then is that you would go ahead and create the plan sheets at that 15%.
Well, and actually, the current workflow in CAD, when the owner of the firm says, well, why aren't you at this point? Why haven't we given a snap of drawings to the owner? And when you have the model, it's like, wow, look, when you made the point, it made me think of it when you said you were 15% schematic and you decided to go to Revit, and when you saw 15%, when you recreated it, like, oh my God, there's all this information.
It's pretty advanced.
We're so much farther ahead than we would have been in CAD.
Well, I think the challenge with that methodology is if you just plot the drawings that you get out of Revit at that stage, you'd have a lot of problems with annotations not being there. And so what you'd end up having to do is you'd spend a whole bunch of time getting the drawings to look good. And I think that really, that's trying to get our new process to fit into the mold of our old process.
Trying to get the model to look good, that's CAD 1.0.
Hey, Greg, we're going to talk to you after, okay? You've hit my 3-comment limit. Sorry.
This is the question the other way around. Are you going to review the 3D models by the subcontractors and approve the models by the contractors? Or are you only going to approve?
That's a good question. I don't know the answer to that. I think what we have done on some projects, and on that Battle Lab project, is yes, we do. We bring their model into Navisworks and we clash detect it ourselves. And what we have also done is reviewed paper shop drawings with the assistance of a Tekla structural model or whatever from a fabricator. But I don't know what we're actually going to get on this job from the subs. And I think it's going to vary based on the subs. Contractually, we have to approve shop drawings, and I think I wouldn't be surprised if they come in paper form.
On the opposite side over there? Oh, you already asked a question. Somebody else.
Has there been interest from your facility managers in managing assets that aren't architectural, so furniture, things like that? Is it something that's built into your model? Or
That's something that we thought FM Desktop was going to do for us on that, and just shows, don't hit all your hopes to one software platform, Autodesk. So they were very excited about that, and they thought they were going to do that, and especially for sophisticated FM guys like Mike Lilia. But it's something that, if Mark Pinsence was still here, that is something that the Air Force is working on. But since it's FM side, for good or bad, it's something that I don't really have overview over. I mostly do architecture and the construction side. But yeah, very good question. It's something in the future. Yes. Any question for somebody else who hasn't had a question? Okay.
Well, this question comes from experience. After you're a little further in the process now, and you know that the MEP LP subs will be doing their own models, and they'll be class protecting their own. Do you think it was worth the time that you spent into it to completely class protect your design?
Right. Well, I think the question was, did it make sense for us to clash detect our MEP design models, knowing what we know now about what the subs are going to do? And I think the answer to that particular question is yes, we would have still clash detected those models, because we want to, our client needs to be able to run clash detection on the file that we give him and have it come out pretty clean. Now, the other question there is, would we have gone to the level of detail that we did with those MEP models? And I think the answer to that question is probably no. I think it would have made sense to keep that on a lower level of detail.
I think on design, we're moving towards design build anyway, so for us, we're very glad to see how this process went and what things we would encounter in design build. So definitely there on a traditional project like this. Maybe not, but I feel like our standards are raising. So I'm not going to tell you we're raising our standards, so up yours. But that's what I thought of. That's why I'm laughing to myself.
Right.
But we are. That's something that I think is if we want to virtually build the building before we build it on site. We don't want any more problems out on the site. So that's
right.
If we have to do it twice, then so be it. But that's the kind of level that we want.
That was what I was going to be my point. Was should we virtually build it twice?
Yeah.
So
yes.
Maybe so. Yeah.
Yes.
How many quantities do you guys take out of models for QS in terms of pricing and quality assessment?
Mm-hmm. I think we actually use some of the architectural quantities out of the model for our quantity takeoff. I'm pretty sure we used drywall because they had gone to the level of detail of putting in the floor finishes and wall finishes and that kind of thing. I think we actually pulled that information out. I know we took the steel quantities out. I'm not sure about on the MEP side.
I think you did concrete too. I don't know, or I know Clark did because
Okay.
they self-perform concrete. But yeah, no, that's the we want to start getting those downstream benefits. I mean, especially the easy ones like 20 takeoffs. So. Okay, we're at the 9:30 point, so if you do want to make a break, but we can still sit here and ask questions on the mic or talk to you in person or whatever you'd like.
Thanks for coming, everybody.
Thank you very much.
A lot of questions.